Salam and welcome everyone. So today we're going to be working on the question on the screen that says use the van der Waals parameters for chlorine in the resource section to calculate the approximate values of number one, Boyle's temperature of chlorine gas from the formula TB equals A over RB, and number two, the radius of chlorine gas molecule regarded as a sphere. So the first thing you have to note is that we're told to use the van der Waals parameters, but we weren't given. But in the question, we're also told that it's in the resource section of our textbook. Now I'm going to write it from the resource section of the textbook that I'm using, which is just the Atkins Physical Chemistry textbook, the 11th edition. And at the back of the textbook, you have the resource section. So from the resource section, I can write out the A value to be 6.260, okay, atmosphere, dm6 divided by mole square. And then the value for B equals 5.42 times 10 raised to the power of negative 2, okay, dm cube per mole. So that's basically the answer. Yeah, that's basically the values that we're supposed to use. So the first question requires us to determine the Boyle's temperature. So the Boyle's temperature is TB equals A over RB. So that's the formula. All we have to do is just simply substitute. So first of all, substitute the A. So we have 6.260 atmosphere, okay, dm6, okay, divided by mole square, okay, so that's A divided by, so that's the unit, um RB. So R, we know that to be the gas constant. And in this question, because of looking at the units, we know that the gas constant that we're supposed to use is going to be the 0.08206 dm cubed, okay, atmosphere divided by mole Kelvin, just because the unit for the parameters that we're dealing with is in atmosphere and is also in dm6, then we know that we're going to be using this. If it's a question where we have a different unit, maybe we had joules or we have pascal, kilopascal, meter cube, then we're going to be using the other gas constant 8.3145. But in this case, we're going to be using 0.08206 because the units match. So times the value for B, so times 5.42 times 10 to the power negative 2 dm cube divided by mole. So cancel out atmospheres, okay? You cancel out atmospheres. You cancel out mole, cancel out mole. You cancel out the second mole, you cancel out the second mole. So you have dm6 and then you have dm cube, dm cube. Well, cancel out dm cube here, you get, and you cancel out the dm6, you get a dm cube. Okay, and then you cancel out this. So basically, what we have left is just the unit Kelvin, which matches it because we're solving for the Boyle's temperature. So what you just do next is just simply TB, okay, equals 6.260, okay, divided by all of this information down here because I've successfully removed all of the units. So that will be divided by 0.08206, okay, times 5.42 times 10 to the power of negative 2. And of course, this Kelvin here, when you do the mathematical calculation, is just going to be here. It's going to come up from the denominator because that's how what you're supposed to have. So when you input the numerical value here, 6.260 divided by 0.08206, right? Times 5.42 times 10 to the power negative 2, TB is just simply going to be 14.0748, okay, times 10 to the power of 2 Kelvin. So that's the answer. Now, let's not forget that in our question, we have the values of the van der Waals parameters given to us. We see that this one is in 4 sig figs, this one is in 3 sig figs. So what we're going to do is that we're going to pick the lowest number of significant figures, and that's how we're going to put our value, our final answer value. So therefore, we end up with putting this answer in 3 sig figs, we have 14.1 times 10 raised to the power of 2 kelvins. So that is basically the answer to this. That's how you find the Boyle's temperature. So that's it. Now the next thing you have to do is to find the radius of the chlorine gas molecule regarded as a sphere. So what you do is for you to note this. Now I wanted to mention, because some of you may be wondering how some of these questions come into play, you have to like review your physical chemistry book and also use my videos as a form of guide to answer those questions. So this one now, So in order for us to find the radius of a van der Waals gas, there's a particular formula you have to use, and that formula has been derived. Although I'm not going to be deriving it in this question because all I want to solve for is the radius. So stay tuned. I'm going to be deriving the formula in future. So just like stay tuned for future videos. So looking at the textbook and basically deriving the formula to find radius is just B with this approximate equals to equals 4 the volume of the molecule, okay, times the Avogadro's constant. So number of atoms. So this is basically the formula you're supposed to use. Where B is the Van der Waals parameters that we already know the value of. So that's good. We know what the Avogadro's constant is, Na. We know that to be 6.022 times 10 raised to the power of 23 per mole. So that's Avogadro's constant. But then you can be wondering, what is the volume of the molecule? What does Vm stand for? Well, volume of the molecule is simply, going back to our question, we see that we're told that the radius of chlorine gas molecule regarded as a sphere. Well, as the volume of a sphere is just simply 4 over 3 pi r cube. So we're knowing all of this information. That is basically what is necessary. And of course, we have the value for 4. So let's just write out everything. So writing out everything, we see that we have B is actually going to be equals to, or discretely, you have 4, okay, times 4 over 3 pi r cubed, okay, Na times Na. So making equation, okay, in terms of RQ, we get R cube, okay, equals 3B divided by 16, okay, pi Na. By the way, pi here is going to be the constant, which is 3.142. So I'm just going to say 3.1416 because I want to make sure that I use as much of the raw value as possible. So it's 3.1416. So we just simply substitute. So you have r cubed becomes 3 times the value for B. Going back up, we see the value for B to be 5.42 times 10 raised to the power negative 2 dm cube. So that would be 3 times 5.42 times 10 raised to the power negative, sorry, times 10 raised to the power of negative, yeah, 9 raised to the power negative 2 dm cube per mole, okay, divided by 16 times pi, which is 3.1416, okay, times the average Avogadro's constant. So that would be 6.022 times 10 raised to the power of 23 per mole. Okay, so of course we cancel out the mole, we input this information in our calculator to just basically get, not the whole thing, I'm going to break it down. So numerator first, so that will be 3 times 5.42 times 10 raised to the power of negative 2 dm cube. That's just simply going to be 0.1626 dm cube. I don't want to rush you guys, that's why I'm breaking it down. And then multiplying the values into denominator, 16 times 3.1416 times 6.022 times 10 raised by negative 3. When you input down your calculator, you get 302.699 times 10 raised to the power of 23. So yeah, when you do all of that information, you end up with 0.0005317 times 10 raised to the power of negative 3 dm cube. So that's it. So of course, we do the needful and say r cube. Sorry, not r cube. Now it's going to be r. And then we find the cube root of this value here. Of course, I'm going to rewrite this in a better way. That's going to be 5.3717 times 10 raised to the power of negative 27 dm cube. That's how you do it. Sorry, let me rewrite the cube root. Just cover it all. So when you do that, you input this information on your calculator, you have 1 point. That's so over here you have 1.751 times 10 raised to the power negative 9. And you see this dm cube, because we do the cube roots, it's just going to be dm, so decimeter. That's going to be the radius. But we also know that because we're dealing with a question in chemistry, we have to put in the lowest number of significant figures that came with the question. We see that the number of significant figures for what we have in the question for the value of B is 3 sig figs. So we use this value and we have to put this answer in 3 sig figs. So you end up with R, okay, equals 1.75 times 10 raised to the power of negative 9 decimeter. And this is the radius to answer this question. So if you have any questions, please put in the comment section. This is basically how you solve this question. There is another question that will be coming up in another video where I'm going to be doing another type of question from the textbook. So make sure you stay tuned. If you have any questions, again, put it in the comment section. If you're a student who is trying to succeed in all your STEM related courses, make sure you email me at shahabituran@gmail.com, because I tutor students in middle school, high school, and college to be the best version of themselves while they're studying STEM in school. So if you're trying to be successful and you want my tutoring and mentorship services, make sure you don't hesitate to email me at shahabituran@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.